Back in the early 80s, most gamers went for Commodores and Apples. The funny thing is that the comparatively colossal business like IBM and its clones turned out to win the gaming market in the end. Today we're going back in time, all the way back to August of 1981, when IBM made one of the most significant machines in the industry to this day. If you're into collecting vintage computers, the 5150 with the fluorescent green screen is an absolute must. The thing is, you can't just buy one of these machines off eBay and start playing DOS games on it. If you do, it will probably blow out the magic smoke and create spectacular crackling noises. And the levers on both floppy drives will probably break within a few months of use. So today we are going to fix all the common issues with the very first IBM PC. We are also going to make it quiet enough to actually use for more than 10 minutes. I have already restored the 5151 display and the Model F keyboard, and I have repaired both floppy drives. The display had stuck adjustment pots and badly yellowed screw covers on top. Both drives needed a head alignment. And I have replaced the foam pad inside the legendary Model F. And apparently something has broken since I used this machine the last time. And I think that's a keyboard error. Well, it still boots, so that's a good sign. Okay, so I pulled the keyboard cable out of the machine and put it back in. And now the error is gone. So hopefully it just needs some deoxit in that connector. Okay, let's get inside and start fixing stuff. Aside from aligning the heads on the floppy drives, I have only cleaned this machine. At least if I remember correctly. It's been a while since I had this PC out. So there were 2 revisions of these 5150s. And this machine has the early board that can only take 16 to 64K. Luckily I have an extra RAM card. Unfortunately it's missing the badge back here, so we might snatch one from a lesser machine. Because aside from missing that badge, this machine is mint. And after having removed those screws, we can now pull the lid off. And if it gets stuck, it's quite likely this thing here that gets jammed behind the power supply here. And when you work on these machines, bolt head screwdrivers is definitely your friend. You can use flathead screwdrivers too, but then there's a risk of slipping off the screw and mess something up. The 5150 originally came with an MDA card to match the 5151 display, but I'm using it with a Hercules card because it can do graphics on that fluorescent green screen. So this machine has this 64 to 256K memory card, and it's partially populated with these really lovely ceramic chips with gold tops. And this bank here is still empty, so I'm gonna check and see if I have some more of these chips. And the 5150 came with 2 floppy drives and didn't have a hard drive, so this controller can only take floppy drives. 2 internal drives, and I think it will take 2 external drives too. So let's remove those drives, because they need service. And these drives are huge, compared to what came just a few years later. And you decide which drive is A or B by putting this resistor pack in one of these 2 sockets. Now we can just pull these drives out, unless you forget to remove the power cable first. And these could be really badly stuck. And since the PCB is so flimsy, I guess you could easily crack the PCB while trying to remove that stuck connector. So I'm gonna try to gently pry on it with a screwdriver, and then I'm gonna put some deoxit on it so it will come off easier next time. Now it's much easier to remove the drive. And as you can see, this machine is in an incredible condition. It is as clean as if it were factory new. I did clean it a couple of years ago, but I only had to remove some minor dust. So someone has stored this machine really well. That awesome power switch has somewhere on the text here. So someone has enjoyed this machine and taken very good care of it. The power supply is held in place with a couple of screws from the back. And by the way, the serial number is in 350,000 something. So these machines were mass produced in really high numbers right from the get-go. The power supply has regular connectors, so no funny stuff like in the PS2. And now I think we can remove the power supply. And the only thing left in this machine now is the motherboard. And it's held in place with just 2 screws and a bunch of clips. And you can identify your board by the text down here. And this is the 16 to 64K board. So the only issue with these boards are these tantalum caps here that we can find all over the board. And they tend to go with a loud bang. And if you're out of luck, they will destroy something on the board. So I'm going to replace them. Okay, let's start by checking some dates. So 1982-45 and week 38. So quite late 1982 board. By the way, these machines don't have a BIOS like you have on more modern machines. Instead you have these dip switches here. So if you change to color graphics, or if you add some more RAM, you have to change these switches to match. Tantalum caps are polarity sensitive, so the cap and the board is clearly marked with polarity. And these caps are marked 106, and that is the same thing as 10 microfarad. And I was actually expecting 3-legged caps on this early board. But as you can see, these caps only have 2 legs. So if you know when they're switched, let me know in the comments, because I thought that came much later than this board. And there are 17 of these caps in total. This board also has these smaller caps here. And as you can see, they are not marked with polarity, neither on the cap or the board. So these are regular ceramic caps, and there's absolutely no point in replacing them. I guess we'll add some fresh solder. And these take their sweet time to melt. So I think there are some really thick ground planes inside this board. So I'm gonna crank up the heat on the desoldering gun. And try with 450. No, I think the solder is still left in that through hole. Well, in that case, I'm gonna snip one of the legs off. And then I'm gonna heat up the leg. Wow, that takes forever to melt. This is almost as bad as a modern board. And I think this pin is a bit bent. So that makes it even harder, but here it is. Let's do the same thing with the remaining leg. Damn, that was pretty tough. Now let's try with some flux and some fresh solder. And see if we can clean out those through holes with the desoldering gun. And no! Okay, let's try with desoldering needles. So I'm gonna heat up the solder and then try to push the solder out. And I think that works. Yeah, that did the trick. Let's try with this one too. And I'm probably skipping ahead here, but I am of course heating up the pad for about 10 to 15 seconds. Okay, so desoldering needles is the way to go with these boards, apparently. Well, this left quite a lot of solder on this side of the board. So let's add some flux and some good old solder wick. Well, that went right back into the through hole. Oh crap. I guess we'll use a needle again. I wasn't expecting this to be a rough desoldering. I thought this was a quick and easy job. But apparently I was wrong. Well, the board isn't too badly scratched up at least. And we better clean this mess up before we put the fresh cap in. and mining the polarity. Okay, let's see if it's easier to solder than desolder. And to make things a little bit easier for the next person to replace these caps, I guess in about 30 or 40 years, I'm gonna straighten up these legs. Well, I guess recapping one of these boards does require a decent soldering iron. Well, I guess the question is whether that first cap was an exception, or if they are this tough, all of them. Let's find out. Now, most of that solder is still left on the board. Well, I guess we'll use the same method here. Now I have a smaller tip on the soldering iron. Well, let's hope it works anyways. Yeah, the legs are a bit bent, so that makes the job a little bit harder. But at least it works. And we've got a solder ball on the board. We better take care of it. Otherwise it will short something out. Well, I forgot to turn the camera on. But I managed to remove this cap here by snipping the legs off and then heating the pads and using solder wick to clean the holes out. So we'll try that again on the next one. But I stopped here because while I was removing this cap here, I noticed something fishy going on here. There's a large solder blob here, and it's actually kind of loose. So something is wrong here. Let's see what it is. And apparently it's the leg of R11 here. So hopefully this is an easy fix. I guess we might as well fix it, even if the board is actually working. So let's try with some fresh solder. Oh, I see. It's actually missing the pad. At least I think so. Let me check with some magnification. And I'm glad to say I was wrong. That pad is fine. It just wasn't properly soldered. And I'm cleaning as I go here, because I don't want to have a large cleaning project towards the end of the video. And if you're playing along, be very careful and check the polarity. Otherwise you will have magic smoke in your lab. Okay, let's have a go at this one in the corner. And I'm gonna snip the bent legs off. Some flux. And I'll try to pull the cap off while I heat up these pads. Yeah, that went well. Let's try with wick. Yeah, that cleaned out that through hole right away. But this one wasn't quite as easy. No, that wasn't enough to clean out that through hole. So let's try the desoldering needle. That's better. I actually wasn't even aware of desoldering needles until a couple of months ago, when a viewer left a comment that I should try them out. So keep the good suggestions coming, and we will all learn from it. Well, I'm glad at least some of them are easier than that first one. Let's hope the rest is as easy as this one. Okay, let's snip those bent legs off. Some flux. And I'll gently pull with the tweezers from the other side of the board. And some wick. So I think we have a winning method here. And that one cleaned out right away too. So this cap was actually even easier. Well, I guess I'll skip ahead here a bit, unless something interesting happens. But this is going pretty smoothly. So I'm not gonna bore you by showing the same thing over and over again. Okay, all happy caps in this corner. I guess I'll just grab all of these caps that are in a row down here. Okay, we're almost done with the recap here. And about half of the through holes cleaned out with just solder wick. And on the rest I had to use the stainless needle. So, extremely useful tool on stubborn boards. And it's basically just a stainless hollow needle. And I think I paid just a few bucks for it on Amazon. Okay, another row of happy caps. And we're almost finished here, so I'm gonna skip to the end. But I definitely recommend getting one of those needle tools if you want to fix one of these boards. It made the recaps so much easier. And if you're playing along here, by the way, These are 10 microfarad caps, and they are rated for 16 volts. And I found 17 of these buggers on the board. So let's move on to the power supply. And the usual disclaimer applies. Don't poke around inside power supplies without proper training. The components inside may contain high voltages, even with the cord unplugged. That being said, it's using T15 security bits, 2 of them, and the rest is a 1/4 inch bolt heads. So pretty beefy tools for a PC. Well, it's pretty clean. There's a very small amount of dust, but the fan isn't clean. And I usually clean the fan when I have a look inside the power supply. So I'm gonna assume that I have not been inside here. Okay, so here is our noisy Panaflow, and it's actually a 12 volt fan. I was expecting a mains fan inside here. Well, that's actually a good thing, because the new fan we're gonna put in here is going to be a 12 volt fan. And here is our main issue. These 2 bloody RIFAs, they tend to go with a bang. And when they do, they smell really badly. And that smell stays in the studio for weeks, sometimes even months. And they are mounted on a separate PCB here. So let's remove it. And again, 1/4 inch bolt head screws. That's pretty beefy bolts for a PC power supply. And here's our PCB. Okay, let's add some fresh solder. And by the way, if you like this type of content, let me know with a thumbs up. And this cap is a bit harder to reach, but I hope I don't have to remove that PCB to get that damn thing out. Well, at least this cap here is easy to reach, but I should probably use a slightly larger nozzle. And on many PCBs, these RIFA caps have 2 sets of holes. And that's a good thing, because the replacement caps I have are a bit smaller than these original ones. And off you go, little RIFA. And it's a 0.1 microfarad X2 cap. And the lower cap is a bit harder to reach, but I think we can get it out without removing the PCB. And off you go. Nasty little smelly RIFA. This is a bit hard to get on camera. I'm doing my best here. This one really wants to stay in with bent legs. And here it is. And as you can see, it has started to crack. And that is what's causing them to pop and release the magic smoke. And this one is definitely pretty badly cracked. And my modern replacements actually had an even smaller footprint. So I had to bend one of the legs ever so slightly to make it fit. But I don't want to wait for shipping and put this video off for a week. So let's work with what we've got. And let's be nice and straighten up the legs. Although this cap is not likely to ever be replaced again. Not even in 40 years. And we might as well keep things nice and tidy and clean up that flux. And the lower one is a bit trickier to reach, but it's definitely doable without removing this PCB. And this is all you have to do with the power supply. But we're not going to stop here, because I also want to make this power supply a bit more quiet and more enjoyable to use. And we definitely need to snip those legs off. We've got mains power here, and they are sitting very close to the case. So let's be safe and snip them off. By the way, here's that desoldering tool I used earlier. And it came in a kit like this, with different sizes, and they cost next to nothing. So do yourself a favor and get one of these kits. Okay, let's take care of that noisy fan. And I think IBM tried to make it quiet, because they have used this foam pad between the case and the fan. But as you can see, the fan blades are really small. So I guess it's spinning at a very high speed and causing all that racket. And here's our replacement. So we're gonna go with the Noctua Redux NFR8. Well, I couldn't find a spec sheet, but I'm sure our new fan is a lot more powerful than this fan from 1982. And the next issue is that we can't use these modern screws on this power supply. So we need to reuse these clips. But they won't quite fit on two of the corners of this fan. So we need to snip some of this stuff off and make some more room. So that should take care of the problem. And now I think these clips will work on this Noctua fan. And the next issue is this weird connector here. So we're gonna have to reuse it. So I'm gonna snip both cables off. And we're not gonna need a yellow wire. So let's snip that off too. And to avoid getting any shorts, I'm going to use some heat shrink. And the only thing left to do now is to solder these wires. And we're done. And now we only need to apply some heat. And then I think our power supply will be nice and quiet and safe to use. And now I'm just going to clean the PCB off camera, because I don't want to bore you with my cleaning process. But basically my method is to hold the hoover very close to the PCB, and then I just brush the dust off with an anti-static brush. And that's a very quick and efficient way to clean PCBs. Okay, so I got a bit curious. And I decided to open up another power supply from a 5150, and this machine seems to have a much nicer power switch without any wear, so we might as well snatch it and make our machine mint. And by the way, this power supply is slightly newer than the one we are fixing right now, and this power supply has mains fan. So perhaps the early boards had 12-volt fans. And perhaps these mains fans came later. And before I put the lid back on and make a test, I just wanted to mention that the caps look fine. And these are probably safe to use for a few more years. Okay, so the floppy drives. So these tendon drives have a plastic latch here that allows for the floppy to come out. And by pushing on it, it locks the floppy in place. But these latches tend to get stuck and break off, so we need to lubricate a few parts here. However, I have already lubricated this drive, and I did a repair of it years ago. But the problem is, I used lithium grease, and at the time I didn't know that lithium grease and plastic parts don't play well together. So I need to clean that grease off and apply something more suitable. Well, it's been a while, so let's see if I remember how to take these apart. But we've got two screws on the PCB here, and then we need to remove these plastic pieces here. And I think these were made out of rubber, but they feel more like plastic, so perhaps they have hardened over time. And then we have two screws underneath, and I think we can now lift the front piece off if we gently pry on this piece here. And yes, here it is. So this is our problem. This rod here gets stuck into this piece here, and I think that's what's causing these damn things to break off. And then I think we have two smaller pieces that acts as a hinge on this side. So we're gonna have to clean and lubricate these pieces too. And I think this rod here just comes right out. So if you have a tendon drive that hasn't broken yet, you should definitely make this simple service, and it will probably outlast you and your children. And the only thing I'm going to do here is to clean all these parts with IPA, and instead I'm going to grease everything with silicone grease, which is much kinder on plastics. And that's all we need to do here. Well, a bit tricky to get on camera. These pieces are absolutely tiny. I think we're ready for reassembly. So definitely a very easy fix, but a very important one. Yeah, it actually sounds differently with some fresh grease. Well, okay, I guess I'll just reassemble this drive off camera and then just do the same thing with the second drive. I guess I'll have a look and see if I have more RAM chips next. And we're in luck here. So I did find some chips, but more importantly, the dip switches are clearly marked, so we know how to set them. And that could be a big problem with a board like this. If you add more RAM and don't know how to set the dip switches, then you're out of luck. So if I'm not mistaken, we should turn this dip switch off and turn this switch on for 256K. And I just realized that this part number here looks a lot like an IBM number. So I did a quick Google check, and sure enough, this is an original IBM part and a matching card for an early 5150. So there is probably documentation for this card online too. But being so clearly marked, I don't really need it. And since this board is working, I think it's pretty safe to assume that this is bank 4. And before I add some more chips, I'm gonna add some deoxit in all the sockets. I haven't checked yet, but I'm assuming that this card is over 40 years old. So maybe we should replace these tantalums too. And we're in luck, so they are the same value as the tantalums on the board. So I might as well replace these too. But I think I'm gonna do it off camera. But let's check the dates on these chips. So we've got week 49, 1982, and week 52, 32, 48. Yeah, so the dates are corresponding well with the motherboard. So I think it's pretty safe to assume that this machine was delivered from IBM together with this card. The ceramic chips with gold tops, they are from week 37 of 1982. So these are probably the original chips. And the chips I found are from week 38 of 1984. So that's a decent match too. And by the way, these are 4164 chips. Okay, so we should now have 256K of RAM on this board. Well, since we have the board out, we might as well make it a bit faster. So let's remove that original CPU. And instead, we are going to add an NEC V20. And that should give us about 15% better performance. And I just realized that perhaps we can overclock this board. I'm gonna have to do some reading. And perhaps we will increase the speed in a future video. Use the bell icon below and set it to all. And perhaps there will be a follow-up video with some overclocking. If it can be done, of course. I have to check. Well, that V20 seems to work just fine. So the last missing piece is of course an AdLib. That should be the perfect match. So I'm gonna go ahead and do the reassembly off camera. Well, I'm replacing the tantalum caps on the RAM card off camera here, but I thought I'd stop and show you something here. So this board here is using these three-legged caps, and according to -0 degrees, the other pads here are the negative pads. And the caps I have are a bit too wide to use instead of these three-legged caps. So I'm gonna have to bodge a few of these caps and bend the legs to make them more narrow. And then put the positive leg in the middle, like so. Okay, all happy caps on this board too. And I found 8 of these buggers on this board. And same value as on the motherboard. And I almost forgot the badge at the back. That's much better. I actually thought this video would be about how to make your early 5150 perfect. But while recording, I ended up buying some more stuff for this project. So if you're watching this in the future, you will find a link below to a second video. Hit the bell icon below and set it to all. That way YouTube will give you a notification when it's done and uploaded. And now is a good time to watch my video on how to make one of these AdLibs for cheap. I would like to end this video by saying thank you to my patrons. You guys are the best.